Alright guys, welcome to PreCal. This is 2.2.3 and we're going to be doing a bit of a project today. So normally in class we would be doing this, so I really can't have you do it from home unless you really want to try and do this, but what you could, if you print out your own unit, circle and stuff like that. But if you just kind of follow along like me, you should get a good idea of how this works. So I'm going to hop over to my document camera because I'm really not going to need my PowerPoint all that much today. So I have a unit circle here. I have the standard angles which we've been using this year on it, and then I'm going to take a can. In this case, it's a game in a tube, and I'm going to put that right on the center, so you really can't see it. But and then I'm going to take this paper and I'm going to wrap it around my can, and I am going to mark the beginning and the end of my paper. So it's right there, and then here is where I end. So then this is there, 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 there. Oops, not really centered. There. It's easier if I didn't have a document camera in the way. Sorry, this is not the most riveting thing to watch, but I'm almost done. Okay, it's not well done, but I tried. Okay, so we have, pull this out. All right, so here is a blank graph that is very, very long on my on a positive x-axis. So I'm going to take this paper that I made. I'm going to cut it off where I started, so that this is the exact circumference of my circle here. So if I put that on the end, I have markings at every angle as I go around my circle. So there's 0 at the start, and then I have here, 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 here. Oh, probably should be a little more there. Here, 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 do, 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 and then the very end there. Okay. So what those are, again, that's not by no means perfectly measured out, but those are the angles on my circle going around. So this is 0, pi over 6, pi over 4, and so forth. So 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, and 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, almost done, 5 pi over 3, 7 pi over 4, 11 pi over 6, and 2 pi. Okay, so we get effectively all of those measurements laid out kind of flat. So what I have here is the x values on my graph are the angles at different places. Okay. So now I'm going to hop back over to my circle. Okay. So my sine values is what I'm trying to graph here. Now we've gone over how the sine is really just the vertical component on these graphs. So it would be that length there, right? So I want to take this sine value and represent it here at pi over 6. So I'm going to take a piece of pasta, right? I'm going to lay it down here and try and break it off as close to that length as I can get it. So that's approximately the right height. So that, and then I'm going to take that and I'm going to place it here. I would normally glue it, but I'm trying to save time so you guys don't have to watch me glue everything. So then I'm going to do my next one. It'd be there. This is pi over 4. That's a little bit short. It's hard to get these perfect. So here's pi over 4 is that piece plus this piece. Voila. And then we go to pi over 3. Some people like to try and break it at the spot with like a pen or a pencil. Down that little height there. And then there's pi over 3. And then I need one for pi over 2, which is going to be right there. Go ahead and break it at that point. And then there's my pi over 2. Okay. I'm going to do this for the rest for this next little part just to kind of show you, but I'm not going to do the entire thing just because watching me do this is by far not the most exciting thing in the world. So break it there, place it down, mark it here. Place it down and mark it here. And then place it down. Okay. Now I didn't do one for 0, nor did I do one for pi, because at those measurements, it's 0, right? Because there's no vertical part here, nor is there one over there. So now that I have those, put this back. Again, these would be glued down. What I'm seeing is, and I'll kind of do a little dash. If I go to the tops of all of my graphs, I see this kind of curved shape. Like that, right? So it goes all the way across the top there. And now, if I kept doing this onto the next area, right, over here, all of my values on this side, this is the same as this, but it's now in the negative direction, right? So I could literally just take these, and versus me having to re-break them and glue new ones. These would all be the same lengths, but negative, going over here. A broken one. And then again, I'm back to 0 at 2 pi. So then this one would keep on going down to hit the edges of all of these. And head back down to 2 pi, right? So I get this big wave of a graph, right? So I'm going to clear out the pasta. Normally those, again, would be glued down, but just so that you can see it a bit better. I'll try and go over this fairly dark so that we see the general shape that I get for this sine graph. Like that, right? Looks pretty good. Okay, so then let's kind of make a prediction, right? If I keep on going, right? If I go around my circle again, I'm going to start hitting these exact same values. So I'm going to hit these again. So I could really copy this, place it over here, and I get the exact same graph again and again and again, depending on the number of times I go around my circle. That is why our sine graph has that kind of big curved shape to it. Okay. All right. So that is where we're going to stop for today. Tomorrow, our main focus is doing the same thing, but for the cosine graph down there on the bottom. So we hop back over here, and I will give you guys the homework for day 1. It's going to be 77 through 84, and then I will talk to you guys next time.